Okay, so we're going to talk about density, which is a subject that you should have already known before now. You should have learned about it in previous science classes as well as potentially in your math class. All right, so density is the ratio that compares the mass of an object to its volume. I typically will say I love density, and that is because the formula, um, the mass over the volume, looks like the mass over the volume, makes it look like a heart. So mass over volume. Okay, so the density of an object is its mass over its volume, mass over volume. Now, mass is going to be measured in grams, and volume is either going to be measured in cubic centimeters or in milliliters. It could be measured in other things like liters, or you could have it instead of cubic centimeters, cubic meters. It just has to be a cube thing because remember, to figure out the volume of something, there's two ways. One way is by water displacement, and the other way is by measuring the length times the width times the height. And if you're taking three measurements, you're going to get a cubic measurement. You're going to get something cubed. All right, so you can calculate the density. Density equals mass over volume. I generally will think of it in what I like to call the triangle of fun, because that way I could figure out with no work whatsoever any of the three variables by saying density equals mass over volume. Okay, so if I make this three triangle thing and I want to find density, it's mass over volume. But what if I wanted to find volume? Then it's mass over density. What if I wanted to find mass? Then it's density times volume. So this triangle helps me to solve for any of the three pieces of the problem. Please be sure you always put units. In this class, you will find out no units means no answer, and that means no credit. So make sure you're writing the units on your problems. All right, so let's give an example for this concept of density. So if we know the formula is mass over volume, density equals mass over volume, and they give me the mass of 2.5 and the volume of 26.3 milliliters, what would the density of this item be? So all it is plug and chug. So density equals mass over volume. I use my handy dandy friend, the calculator. I get 0.095, and that's grams per milliliter. While we're at it, let's talk about significant figures for just a second. This number, the mass, has 2 digits in it. And this number, the volume, has 3 digits in it. And so this number has 2 significant figures. We abbreviate that concept by saying sig figs. So that has 2 sig figs. This has 3 sig figs. And whichever is the lower number of figures is how much your answer should have. So my answer should only have 2 significant figures. That's why we stopped the numbers when we did the calculations. If you take 2.5 divided by 26.3, you don't end up with a zero. You don't end up just at 9.5 here. You end up with 0, 5, 7, 0, 3, 4 after that. Why did I only give 2 significant figures? Because my lowest number of figures in the question was 2. Another way to write this would be 9.5 and then how many places? 1, 2. So that would be to the negative 2. E negative 2 is another way to see that you have two significant figures. That's 9.5 times 10 to the negative 2. This and this are the same. That's equal. Those two things are saying the same thing. So E negative 2 and times 10 to the negative 2 is the same. Then let's look at the units. You took grams and you divided them by milliliters. That's why your units are grams divided by milliliters. Whatever you do to the numbers, you do to the units. Okay? All right. So here's an example problem for you then. The mass is 19.6 grams. They did a little conversion here for you. They gave it to you in decograms, but they're asking you to solve it. So you have to get that to grams. That's the base unit. And the volume is 15.7 milliliters. So the first thing you're going to do is pause the video, solve the problem, and then come back and see what the correct answer is. Pause the video now. Okay, hopefully you set your problem up. Mass over volume, 19.6 divided by 15.7. There are three significant figures in each of these problems, so my answer comes out to 1.25 grams per milliliter. Okay. Next problem, pause the video, solve the problem. They're asking you to solve for density. Okay, so you've solved the problem. Mass was 3.44 divided by the volume of 0.95. 0.95 actually only has two significant figures. So this is not the correct answer in sig figs. How would I get this answer to be the correct significant figures? This is 2 sig figs. This is 3 sig figs. So my answer can only have 2 sig figs in it. So the answer would be rounded 3.6, that's a decimal point, grams per milliliter in the correct significant figures. Don't forget the units. Don't forget the significant figures. It always goes by the lower number of figures in your question. All right, here's the problem. They're asking you to solve for volume. Go back to your equation. Remember, density equals mass over volume. So if you put that into your triangle of fun, you've got density equals mass over volume. How do you solve the volume? That's mass over density. So if you know that density equals mass over volume, you have to have that first formula memorized to fill it into your triangle. Then you can solve any problem, whatever thing you're trying to solve for, whatever's left is the equation. So pause your video and figure out what the volume of this equation is. Okay, so I've got the mass over the volume. What is going to happen here in my units? So the grams are going to cancel out. Please keep in mind I am solving for volume, so I should have some underlying knowledge that the volume is going to come out in milliliters. And let's look at the digits here. So the problem says 14.8 divided by 2.34, and actually the number of significant figures, that's 3, and that's 3. So my answer should come out to 3 digits. Now here in this problem, they said 6.3, but that's not correct. The correct answer is 6.32 milliliters, because this needs to be in the right number of significant digits. Okay, there are only 2 here, and I needed 3. All right, so we're going to be doing an experiment, and you're going to need to be able to figure out the two different aspects. So what do I need to solve for the mass? Mass is going to be using either a triple beam balance or an electric balance, an electric scale. So either one of those two things is going to get me my mass. And for this lab, we are using irregularly shaped objects, so we're going to need a graduated cylinder. A graduated cylinder is going to use water displacement to figure out the volume. So how much object's volume is you take the number, you have to know how much water you put in here first. So let's say I've got 2 milliliters of water in here first. And when I put 2 milliliters of water in there, and then I put my object in there, you'll see the object raised up 2 more units, up to 4 milliliters. So that means that it's 2 whatever the units are of this thing. If this was, it doesn't have to just, it could be liters even, but in this graduated cylinder, it's 2 more units up. That's how I know how much this object's volume was. So that's using water displacement to figure out the volume of the item. All right, so that's what we're going to be doing in this experiment. So you're going to figure out the density of different irregularly shaped objects. So you're going to need to know both the mass and the volume of the objects. You can find the volume of the irregular shaped object by placing it in water in a graduated cylinder. Please be careful, don't just drop heavy objects into the bottom of a cylinder. So find the mass of the object and record it on your data table. Add water to your graduated cylinder. Be sure that you are reading the meniscus line. It curves in the cylinder, and so you want to look at the bottom, the lowest point on the meniscus. And you're going to put the object in there. Caution, heavy items will break the glass. So if you've got a heavy item, you could possibly you have a plastic graduated cylinder over at your table. Use that for the heavy items so that you don't break the glass in the bottom of the graduated cylinder. There's also some string you can tie to the item and lower the object down. The object has to be completely underwater. So if the object floats, and its density is less than 1, which is the density of water, you will have to take a stir rod to push down the item. Be careful, make sure that the stir rod isn't also under the water, because the stir rod has density. So you're going to only put the item under the water. So you're going to go ahead and collect your data. Make sure you're making a data table. Data tables have rows and columns that are clearly labeled. Be sure to include the units on your data table. A data table is not a random list of stuff all over your page with densities listed out randomly and masses here and volumes there with no units on them. They are inorganized data tables. All right, so be sure that your data table is indeed a data table. Then you're going to use the initial and final volume readings off your graduated cylinder to figure out the volume. You're going to record that on your data table, and you're going to use these calculated volumes to measure the density of your item by taking mass divided by volume. Record all of your items onto your data table. And then you're going to answer these questions. Explain why you cannot use water displacement to find the volume of a sugar cube. Describe another way to find the object in this lab's volume without knowing the density or the mass, how to figure out just the volume of the item. And you can answer both questions 3 and 4 directly under the data table that you use to house questions 1 and 2, basically. Okay, so then once we're finished with that, we're going to need to figure out percent error. Scientists want to know what percent of the accepted value their error is. And so the way you get percent error is you take your error, which is your experimental data. That's the data you just got when you did the experiment, your answer. Okay, so that's your answer to what is the data, minus the accepted answer. There's gonna be somebody that's already done this before you. So what is the value that is known for that item? So you're going to look at the known item's value and do a subtraction. Now, there's two little straight lines on either side of this, and that means that is the absolute value. That's the absolute value, meaning they're always going to be positive because it's how far on a number line, how many places on a number line is between these two numbers. So it's always going to be a positive value. So it honestly doesn't matter whether the known value or your answer is the larger number when you do the subtraction problem here, because it's an absolute value. So it's your answer minus the known value divided by the known value times 100, because the accepted value is used twice in the percent error problem. So the percent error is the ratio of an error to its accepted value. So here's an example. If you found out that the accepted value for a mass of an item is 5.67 grams, and the accepted value, that's your experimental value. You did the experiment, it's that. And the accepted value is 6.1. So it is the 5.67 minus 6.1. That's coming out to a negative 0.43. But remember, in the formula, you use the absolute value. So it's a positive 0.43 divided by the accepted value again. You use the accepted value twice in the equation, once in the subtraction problem, and then you divide. And then times 100 to get it to be a percent. So you were 7% off on your calculation. So this was your experimental value. This is the accepted value. Your answer that you calculated in this experiment was 7% off, which means you were 93% right. So being 7% off is a pretty good answer. So you'd be okay with that one. If you get an answer that's a really big percent error, you might want to solve the problem again and make sure that you have the correct mass or the correct volume for your equation is on this density experiment. All right, so figure out the percent error, pause the video, and solve this problem. Okay, so actual minus experimental, and that is 9.4, divided by accepted again, and you're going to times it by 100 to get it to be a percent. That's 11.82%. So it is your error. That's the difference between the two, the actual minus the experimental, that's error, divided by the accepted value times 100. That's about 12% error. That's 88% right. So not too bad still. All right, so after you do this lab, you're going to need to come back to this slide in the video or go to the PowerPoint that is in your Canvas to get the accepted values of the different items that are in your lab experiment. So these are the accepted densities of the items in this lab. When you're finished with this lab, you can check the mastery of your understanding by solving these three problems. You can pause the video and come back to the correct answers. The correct answer for the first problem is 1 gram per milliliter. The correct answer for the second problem is 1.5 grams per milliliter. And the third problem is 3 grams per milliliter. This is actually not the correct number of significant figures. So 2.7 divided by, I want to figure out the volume. So oh no, and this next problem, this last problem, they've given me the density and they've given me the mass, and I want to find the volume. So that's mass divided by density. 8.1 divided by 2.7 is solid number 3. But because this number here is two significant figures, the answer should have been written 3.0 grams. Okay, so it should have been written 3.0 grams to have the correct number of significant figures. Okay, that's it.